Welcome to an introduction to quantum physics. This first chapter is called A Step into a New World. If you are interested in physics, quantum physics, how the universe was created, or just want to learn something new, you are in the right place. Quantum physics, by dictionary, is the branch of physics concerned with quantum theory. But it is so much more than just a science. Quantum physics rewrites classical physics as we know it today. It teaches us something that goes beyond this world. This new science, discovered in the year 1900, has revolutionized the way scientists think. Since then, theories like Schrödinger's cat, Planck's constant, Einstein's theory of general relativity, M-theory, string theory have been made plausible due to quantum physics. Quantum physics is a study or branch of science that deals with how different subatomic particles react with each other. Particles in an atom are protons, electrons, and neutrons. Outside the nucleus of an atom is electron shells. The particles between the electron shells are believed to be quantum particles. Between the electron shells of an atom is equivalent to almost a new world called the quantum physical world, where the laws of classical physics are completely discarded. Quantum entanglement is when two or more particles become connected at a subatomic level. An example of this is if you roll two dice and they both come up with the number 6. These two particles, represented by the dice, are telepathically communicating to each other faster than the speed of light, and telling each other what they're gonna do before someone can observe them. So these two particles are communicating with each other, telling them what they're gonna do, what the outcome is gonna be, how they're gonna act. And due to the observer effect, a scientist cannot observe that this is happening, and that's why the two particles are acting the same. Quantum tunneling is when a particle can penetrate an energy barrier that's higher than its own kinetic energy. In simpler terms, this means that a particle can move through an object that contains more kinetic energy than itself. Kinetic energy is the energy an object has when it is in motion. An example of quantum tunneling is a particle traveling through a door. Theoretically, in the quantum physical realm, which is the space between the electron shells of an atom, particles are capable of quantum tunneling. Today I will be discussing wave-particle duality, which is when waves can exhibit particle-like properties, while particles can exhibit wave-like properties. For example, fundamental entities like light and electrons can behave both like a wave and a particle. A way that scientists test this is through the double-slit experiment. The double-slit experiment shows that when particles are sent through two slits, these particles can create an interference pattern, which is a series of bright and dark bands. This only happens when a scientist observes them, whereas when a scientist does not observe the particles passing through the double slits, the particles behave like particles and only go through one slit. Therefore, the particles act both as a wave and a particle. The uncertainty principle originated from Werner-Heisenberg states that there is a limit of precision to which certain properties of particles are measured. In simpler terms, this means that scientists are not capable of measuring both the exact position and the exact momentum of a subatomic particle at the same time. The more accurate one property is known, the less accurate the other property is known. The product of this uncertainty always will succeed a particular minimum value related to Planck's constant. Quantum superposition is when a quantum system or particle can exist in multiple states or configurations simultaneously until it is observed. In simpler terms, it is when a particle can exist in two states. Although when a measurement is made, the superposition of the particle collapses, and the particle will be found only in one state. Schrödinger was a theoretical physicist and a key founder of quantum physics. He is most known for creating the Schrödinger's equation, an equation which best describes wave-particle duality, as well as creating the theory of Schrödinger's cat. Schrödinger's cat is a theoretical experiment in which best explains the phenomenon of quantum superposition, being in multiple states at once. This theory essentially explains how theoretically, if you were to place a cat into a sealed box, you would not know if the cat is dead or alive. Therefore, the cat is in a superposition state of being both dead and alive. Applying this to a quantum phenomenon, this best explains how one particle can be in multiple states at once, called quantum superposition. Quantum field theory is used to describe the behavior of subatomic particles and their interactions, viewing them as quantized excitations of underlying fields that fill all of space. This theory explains localized energy packets called quanta, phenomenons such as particle creation and annihilation, as well as the interaction of energy changes, although this theory does fail to incorporate gravity. Time dilation is the phenomenon that time passes at a slower rate when near an object with a large gravitational field, or if an object approaches the speed of light. For example, time will move slower while near an object that has immense gravitational force. So 1 hour in stationary time could be 1 year in that object's gravitational field. If an object is traveling close to the speed of light, then the time will slow down for an object compared to stationary time. This phenomenon is closely related to Einstein's theory of general relativity and special relativity. Einstein's theory of special relativity was published in 1905. His theory revolutionized physics because it established the speed of light constant, which is this number. This constant is not regarding motion and is relative to space and time. This theory was the beginning of key concepts such as time dilation, length of contraction, and the formula E = mc squared. His theory states that the speed of light in a vacuum is constant for all observers regardless of their motion. His theory implies that time moves slower for an object near a strong gravitational force or for an object moving close to the speed of light, otherwise known as time dilation. That brings us to Einstein's theory of general relativity. Using his first theory, he was able to theorize that gravity is not a force, but rather a geometric curvature of four-dimensional space-time, which is caused by the presence of heavy mass or a law of energy.